Hey gang, how you guys doing today? Happy Thursday. All right. So pause that and close it out. Alrighty. So things were going great this morning, and then I had some slowness. So I'll keep an eye on it and see how it's going today. I think it should work okay. So let me know if it gets really choppy or something. But it's been working really well, so I'm hopeful we'll have a good day again. Today we are moving on to relational databases and MySQL. Today, actually, we're not doing anything with PHP. We're not going to write our own PHP, at least. So we're going to look at some default controls we have in the database. And 1200 is our Introduction to Database Systems course. Was not a prereq for this class, so that's okay. You don't have to know anything about databases. If you've taken it before, you're probably going to be really bored today. I apologize. We're going to go over some basics of relational databases, what they are, and then specifically the MySQL database server. We're going to try that one out and poke around in it and see if we can play with it and do some stuff. And then next week, we'll get into actually using PHP to talk to that database, to store data, retrieve data, update, the CRUD operations, create, read, update, delete. We'll do those operations using PHP, and that'll be much more interesting. Then we move into model view controller design, debugging, and using form data. And then the last couple of special topics on PHP: arrays, functions, and objects, secure websites, basic auth, and email. I'll also hit after break. And then we'll move on to the Java side of things, JSP and Java servlets. So we are just cruising along. It is week 4 officially. That's awesome. And so we're going to try and do a lot of what's usually covered in 1200 in about 2 hours or so, and see how well that goes, and look at a specific database management system, which is called MySQL. Or I think ours is actually MariaDB, but they're essentially the same underneath the hood, which is cool. So we can still control it as if it were MySQL. Cool. So what we're going to need to do this, our XAMPP controller, we're going to need Apache and MySQL starter. We hadn't started that one before. It should start and just go well. If it doesn't, let me know. But this one, generally, we don't have a lot of trouble with, which is cool. So once we get that up and running, we'll be able to go connect to it. So a couple things about databases first. Let me pull up whiteboard here. I'm going to do a lot of drawing today. Oh, we don't need that one. I can clear that one out. Okay. So the idea about a database is we want to store information, right? Typically, we draw a cylinder picture for some reason. I don't know who came up with it, but sort of draw a little cylinder. And this is our database. Database. Okay, so this is where we store data. A database is made up of lots of different things that go into a database. So typically, we'll say we have a database management system, our DBMS. Its job is to manage lots of different databases, right? We can have all sorts of these things around. Now, the idea is each database, DB, it is for separate things. Maybe they don't always have to have the same type of data. Now, some people have lots of databases, some people have one big one. Again, it just sort of depends on your design philosophy. I'm a fan of lots of small databases because I think they're easier to manage and back up and do all that database management stuff that you have to do that we're not going to talk about in this class. So anyway, we'll have multiple databases. So our DBMS, right, in this case, is MySQL, or really MariaDB, but again, essentially the same thing. And it can handle multiple databases. So what we're going to do is we're going to make our own database for storing some information. We'll just add one. And a database then is made up of tables. Are you guys familiar with Excel? You get columns like that, and you get rows like that. Imagine a table as kind of like an Excel spreadsheet. Right? You can, each column then has a name. So we have specific columns for specific pieces of information. Okay? So let's scroll this down. So if we were to try and do our own table, then we'll say let's pretend we wanted to store some information about a course. So our table will be called course. This is the course table. Okay? And inside of it, we want information about course. Again, this is sort of going to feel similar to object-oriented design when you took your programming classes. Hey, Ray, how you guys doing today? So with the course table, again, we want all the attributes of course. What things do we need to know about course? Well, course has a number, right? So that would be one column. Course has a department. That would be another column. Course has, what else does course have? Number, department. What sort of information do we know about course? Do you think it has like credits? Probably has a description. That's DESC for description. Name. Oh, yeah, course name. Thank you. Name. Okay. So those are all pretty, sorry, name looks terrible there. Let me try that again. Name. Those are all good attributes, of course. So I think 404, you might be thinking about a particular section of a course. A course itself is just the basic course. It's not the section that's being offered at a given date and time by a certain prof. But I know where you're going there. That's good. It's a good thought. So we could. Well, let's talk about that. Let's say, so maybe we did have in here then, if we went that route, maybe we had prof. Sorry, I should put these over to make some more room here. We had prof, and then we had what? Semester, and then we had day, and then we had time. And you might have something like this, right? This is totally something we might have. So now, what happens here? Say this is a 2454 in CIS for 4 credits. The description is PHP Java name. Oh, sorry, PHP Java whatever. PHP Java prof Charnesky. Semester, this is winter 21. Day is Thursday. Time is 1, and we're supposed to go to like 3:45, but again, I don't know, 4:45. We try and drop off about 3, because again, typically a lab class is going to be, half me talking at you, half you trying it with the computers, and unfortunately, I can't watch you try it while I'm streaming here and that sort of thing, and I'm double booked on Thursdays, but that'll give you me time to tell you about things and then you time to try them. That's sort of the philosophy here with our classes. Maybe half and half, maybe a little more lecture than practice time. Depends on the content. So what happens now is we're doing our annual schedule planning, and I want to offer this class in the summer. Say, okay, well, let's add another row, right? So each row is like an instance. Think back to our object-oriented programming. Here's an instance of this course, right? Okay, let's add 2454, CIS, 4 credits, PHP, Java, PHP Java, Charnesky. This is going to be summer 21. It'll be on Thursdays from, I think we're going to do 6 to 9:45. The summer, because afternoons are weird. Okay, sure, we did that. Now what about next fall? All right, well, 2454, CIS, 4 credits, PHP, Charnesky, fall 21, Thursdays, 6 to 9:45. Okay, do you see any problems with anything like this? Not necessarily anything wrong with it currently. Right, it's not too bad. Now, what if, though, I wanted to go, say, change the description? Yeah, lots of repetitive info, definitely. Lots of repetitive info. So every time I have to store this, I'm storing more information over and over and over and over. We'll call that redundant information. Repetitive, redundant, it's the same thing repeated. And if you think back to your programming class, right, anytime you have repeated code, you should feel bad about yourself. That's a good rule of thumb, right? Because you probably could have just had a method. Right? Don't repeat things. Don't repeat yourself. Same idea with our database. Right? Anytime we have redundant data, we should feel bad about ourselves. And again, this isn't the database design course where we're going to talk about trade-offs and why this might not be the best thing, but whatnot. But anyway, relational databases were designed to avoid redundant data, to avoid repetitive data. And one of the reasons is, say if we wanted to go change something, I'd have to change it in every single location if I want to change this description. And back through semester after semester after semester, however far back we want to change that description, that's a big mess, right? That could cause some trouble. And the more repetitive data you have, the more likely you are to not update all of it at once. So it can cause all sorts of problems if your data gets out of sync, right? Where you've changed the new one, but maybe not the old one, that sort of thing. So a better way about going about that then is we say, okay, well, let's take the data that is the same and leave it where it belongs in the course table, and we'll move the stuff that's separate into a different table. So we're going to get rid of all this stuff here. We don't need any of that. And then we're going to whack off this information here, because really that's all... Ooh, wow, the eraser gets bigger as I push down. That's cool. That all belongs to like section information. Or maybe it didn't get bigger. I don't know. There it goes. That's fancy. So then we might have a section table. And then section then is going to have information like prof, semester, day, time, right? Campus probably, room, that sort of thing. Right? But now, how does section know which course it is referencing? Right? We can use our programming terms. How do we reference a course? Well, we need a field here that will tell me what course it is. Now, there's a couple ways of doing this. I have one philosophy, and just because I find it the easiest, there's other philosophies as well. But the way that you uniquely identify a row in a table is called its primary key. We usually say PK for primary key. That's the unique identifier for that instance or that row. And the database's job is to make sure you don't ever have duplicates. Because it'd be really bad if we had this in here twice. Right? But this defeats the whole purpose. So we're going to make sure that we have a unique identifier. Now we could say number and department here make up a primary key. Sure, that's true. We could use that as a primary key. The problem with that is lots of things. It's a composite key of two fields, because you don't want to have department and number in the same field, because then, hey, how do I find all the classes that are CIS classes? Oh, well, I have to look at one field and I have to split the information apart and I have to look for just the letters here. So you want to keep them separate to maintain searchability. Right? It makes it much easier to find stuff if you keep fields discrete and separate and only holding one piece of information. So we could do that as a primary key. I'm going to recommend we don't. Okay? I recommend you just add a field called ID. And ID can just be, usually it can just be an integer, 1 to 2 billion something. If you have more than 2 billion something in a row, sure, good for you. You've got a really big database. You've got stuff going on. It does happen, right? But for now, we're just going to say, sure, an integer. It can just be ID1, ID2, ID3, ID4, ID, whatever, right? So every time we add a course, it just picks another ID number. And the great thing about that is they can be system generated. We just say, oh, just give me the next number. Great, give me the next number. Great, give me the next number. No problem at all. We'll just take an ID here. So I'm going to be ID1 here. And I want this to be the primary key. So that will uniquely identify my course. Primary key. So what I can do here is I can have course ID. And that will reference the ID over here. So this is called a primary key. When you are referencing a primary key in another table, it is called a foreign key, or FK. It's foreign to this table. It's not in section. It is foreign. It is in the course table. And one of the things databases are really good at, relational databases are really good at, is this thing called referential integrity. Referential integrity. Look at that. That's terrible handwriting. I'm sorry. It's just as good as you get on a whiteboard in class. So maybe actually better because it's easier to erase. So referential integrity says if I have something labeled as a foreign key, I can't put a garbage value in there. Hey, Snake. Thanks for coming by. So a garbage value meaning a value that doesn't exist. Right? So if I say, hey, this is course ID 2, and there is no 2 over here, my database management system is going to puke on me and say, nope, no luck, can't do that. The whole thing fails. And again, take a database class, learn more about specific stuff like that, but just know it's no good. It won't work for us. Okay? So it enforces that if you put a number here, it exists in the other table, which is good. We want that. we want to make sure that I'm referencing the right stuff. Oh shoot, I'm losing my bits. Let's see if we come back. So it was so good this morning, and then I had like a spike. Okay, I think it's doing some weird speeds here. I don't know what it's trying to do. Sorry, folks. Let's give it just a minute here. It came back earlier. Excuse me. Whoa, I'm freaking out keeping opening OBS all the time. Yeah, the bitrate is unhappy. Let's give it just a minute. Let me drink some Perrier, watermelon flavored Perrier. Come on. All right, I might be back. How's it now? A little less laggy? Sorry, guys. This technology thing is hard. Okay. So that's referential integrity with foreign keys. Okay, so we might have section. Another rule of thumb, right, when we do our object-oriented design, is that attributes belonging to that noun, again, typically they're nouns, they don't always have to be, but typically they're nouns. Attributes that belong to that noun go into that table. Right? That's how we design things. So all the things about section go in the section table. Okay? So we're gonna follow that design idea when we start making our tables. Right? And if it is related to, but it's another noun, we can use that foreign key to say, oh, well, this is the course information. So not only does that let me reduce redundant data, right, but it lets me make sure that my nouns are very proper, right, and I don't have to store extra stuff. Right? So things about section are who's teaching it, which semester, what day, what time, what campus, what room, sure, that sort of thing. Now, how would we have a list of students in the class? Could I just add another field here and call this students? That says students, by the way. Sorry, that's terrible. Students. I'll just put stu. Easier to fit. Could I put like student, I don't know. You guys actually have an ID, right? All of you have a student ID number. Could I just put like 1, 2, 3, 4, 5, 7, 9, 5, 8. Do you think that would work well? Having just one field with a bunch of values there? No, that's ugly. That's a big no-no. That's a big no-no. Okay? You don't want to have multiple values in a single field. Right? So fields or columns, columns are single value. That's another good rule. Yeah, we need another table. Yep, another table. So maybe we'll have a student table. This is our student table. Right, and it has an ID. So section probably also needs an ID here. Right, again, we're going to put an ID for the primary key on every table we make because I like it easy. It blocked the term FK for foreign key. Oh, thanks, Automod. That was good. That was good. Yep. So student then, right, has information about students. It's got your name. It's got yada, 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 yada about students, right? Sure. All the things about students. We know a lot of things about you, right? Which is probably a good thing, right, if you're going to be enrolled here. So now, how do I put a student in a section? Well, student, do you want a list of classes? No, right? As soon as I say list of something, you should say, single value only, no classes list. Can't do that, right? That's no good. So what we do is if we have, so a lot of times you think of this in relations. I should get back to some of this database terms here. So you might have one thing relate to one other thing. So like a department has one department chair. That's a one-to-one relationship. So if I have a table for profs, right? So like this prof table would actually be probably like prof ID, and I'd have another table off here somewhere for prof, right? I'm not going to put all of the information in here, like what my number is, what my email address is, all that stuff. Like you can get all that from the prof table, that sort of thing. But we'd have a prof table, but like a department would have one chair. That's how things work. right? But one course can have many sections, right? Hopefully we offer a class more than one time. So that's a one-to-many relationship, one-to-many. So we draw all sorts of cool pictures with this in the database class. I like this thing called crow's feet. We'll say there's one of these things to many of those things. Sure. And again, I'm sort of mixing and matching how I'm doing my drawings, but just think in terms of relation. So one course will have many sections, but one section will only have one course, right? You can't have a section of more than one course. That section is for one class and one class only, one course only. Okay, so that relationship here is one to many. Right? If we had that prof table, maybe we'll say there's a prof table over here. Sure, it has an ID field and other info, sure. And then we might have a department table, right? And it might have a chair, and the chair is a prof. So that is one chair to one prof, and one prof is the chair of only one table or one department. So that's a 1-to-1, right? One department, one chair, one prof, one department. Technically, you can teach in more than one department, but you're really a member of one. I don't know. The system's a little bit funny, so don't take this too far. But essentially, that's a 1-to-1, right? But now what we have here with sections and students, we have a section will have many students, and a student will be in many sections. This is many to many. Right? One student's in many sections, one section has many students. We see a many-to-many relationship here. As soon as we say that, you should have alarm bells going off in your head and say, nope, can't do that. That's no good. Not allowed. Okay? We can't do that. In database land, you can't have many-to-many relationships. Right? We could do it in code. I could write a student class with a list of courses, and I could write section. I could write a section class with a list of student in it, and I could do that, right? And my code would be perfectly fine, right? Think back to Java, just have an array. If you have a student class, it might have an array of sections, or an array list, because array lists are so much better than arrays. Arrays are stupid. And then your section class might have an array list of students. We could do all that, sure. Not a problem. In database land, we can't. It doesn't work. And actually, it turns out it will be harder for us in Java land, programming land, to do that anyway, because there's additional things we need to know. Okay, so what we're going to do is we do this thing called a joining table. Joining table. Table. So the joining table, we might call this enrollment. Enrollment now has a section. Enrollment has a student. And these are all IDs, by the way, sorry. So student, right? So one enrollment relates to one section. So that's one section per enrollment, but one section will have many enrollments. That's good. One enrollment will relate to one student. One student will have many enrollments. That's many. Sorry. Oh, you can't see that, I guess. Keep forgetting my webcam's there. I'm sorry. Other things about enrollment, right? Other pieces of information that we're actually going to need somewhere, right, is your grade. We need to save your grade somewhere in the system so we can calculate your GPA. So with our model of many students and many sections in code, well, there was no place to store that grade information. So this is actually, it's a good process to have too as well, even if we're just doing straight object-oriented programming. Right? Many relationships have lots of problems. Right? So this joining table is super useful. Now, there's not always going to be some additional information you need. So not always, but in database land, we're always going to use a joining table. So section is a foreign key, right? And student is a foreign key. So they'll relate back to the section table and will relate back to the student table. And then grade will be where your grade is. So you see how we're looking at what our nouns are, what information we need to store about them, their attributes. We're designing tables, and we're trying to find relations between them and reducing that redundant data, right? Anything in the table should be about that attribute. and just about that. So we want to, if anything is repeated, we can probably pull it out and make a different table for it. We okay so far? I know this is a lot, especially if you've not taken the database class. And if you have, hopefully you're not bored. Okay, cool. So what all this means for us, what all this means is when we want to have data stored on our web server and be able to interact with persistent data, it's going to be in a database. Now, yes, technically you can do things with files. We're just going to pretend not, because most of the time we just don't do that, right? Any company worth anything is going to be using a database for storing data and not plain files. Okay, plain files, there's nothing wrong with them, but like they're not designed for this sort of thing, where relational databases are designed to be good at this sort of thing. And we run into all sorts of trouble, and we'd have to reinvent a lot of wheels to make sure we have referential integrity and we're looking things up and we're doing things fast. Because databases are really good at being really fast for looking up data, which is amazing. Like that's what they're designed to do. And again, there are other database technologies. These are specifically relational databases that use SQL. There's a new up-and-coming thing called NoSQL, and it doesn't actually mean no. It's not only SQL. So it's a database technology that's not just the tools with relational databases, the SQL stuff we're going to look at. It expands beyond it. You have document-based databases. You have all sorts of interesting things that you can learn about. We actually have a class on that. If databases are your thing and you're interested about it, it's pretty cool. But for what we're going to be focusing on is traditional relational databases. And there's nothing wrong with that. Like, this is how everything in the world runs, is in a traditional database. Anytime you order something online, anytime you go to a store and buy something at checkout, it's getting entered in a database, right? All of it's there. It's all getting tracked because we need to store that information. And then once you have that information, businesses can do some cool things with it, do fancy data analysis and analytics and all sorts of good stuff there to sort of see, well, based on what you've previously purchased, how else can we get you to spend more money at our store? So there's a lot of value in having data. So we're going to be saving data around, and we'll be using a database for our project. Okay? Cool. I'm glad it's a sort of, does that mean you had the 1200 class, Ray? That it's sort of review, or like you just have done this sort of thing before? Okay, cool. Oh, awesome. Yeah. Ian's a great guy. Weirdly, I never had a class with him though. But he was the prof actually well before I started school, but back when I was taking my classes at OCC, he was around and running them in the halls. Okay, cool. So I just worry because this is not a prerequisite for the class, so there's no guarantee everyone has actually taken 1200. So definitely want to make sure like the ideas of and the concepts here make some sense. So if we were going to design like a store system and let people check things out, like build a little web store, right? We might have some tables. We might have product, right? These are the things we sell, right? So again, we're going to use like an ID field, and then there's probably like a name and a price, right? And then, we might be tracking like our quantity in stock or something. Again, lots of different ways of going about it here. But we need some sort of information, right? And then someone wants to go buy these things, right? So we probably, again, data is amazing, so we want to track information about our users, right? So we might have a users table, right? Again, we haven't really figured out how this login thing works, so maybe we'll skip user for now. That's fine. Maybe we'll get to that after here. So product, and then when we want to buy something, we're going to create an order. Right, this is a pretty typical example when we're talking about databases here. So order, again, has an ID. An order would be for a specific customer. Again, we're sort of skipping that customer user table thing, but sure, why not? We'll pretend it's there, customer. We'll pretend that's a table. So we'll have the customer ID here, right? That relates. So one customer can have many orders, but one order is related to one customer. Okay? And what other things do we know about order? We might have, whether or not it's been paid. Maybe you can place an order for pickup and you'll pay when you get there. Maybe you can place an order, we'll ship it to you. All sorts of interesting things, right? We can have all sorts of data about it here. But now, how do I have the list of things that I bought? And as soon as I say the word list, hopefully you're thinking to yourself, it can't be one field. Right?